You can go to the next slide. Great. All right. Good morning, everyone. Thanks for joining us. My name is Sarah Husky with 3C Ren. I have started recording this course, which will be posted on our on-demand page. We have Nick Brown with Build Smart Group with us today to go over how to model all electric homes for maximum compliance benefit. But before we get going, I just have a few slides to run through. We are all very familiar with Zoom by now, but we just ask that everyone make sure that you're on mute throughout the duration of the course. If you'd like to ask a clarifying question, raise your hand and we'll ask you to mute yourself. But also I'll be monitoring the chat, so feel free to add any questions into the chat box. And so for those of us who might be new to 3C Ren, we are the Tri-County Regional Energy Network. We are a collaborative partnership between San Luis Obispo, Santa Barbara, and Ventura counties, working to improve energy efficiency in our region by offering free programs and services for building professionals and households. 3C Ren is funded by ratepayer dollars, which are collected through the public good charge found in our utility bills. And the benefit of being ratepayer funded is that there's no cost to those we serve, and we are able to return these dollars back to our local economy, which has historically missed out on some of these funds. 3C Ren currently offers 3 programs. The first is the Energy Code Connect program. If you go to the next slide, thank you. So this program serves building professionals by offering Title 24 support for everyone from plans examiners and inspectors to architects and contractors. We also offer our Energy Code Coach service, which is an over-the-phone, online, and in-the-field support for Title 24 related questions for both residential and non-residential projects. And next slide. Another program we offer is our building performance training, which serves building professionals such as architects, engineers, contractors, and real estate professionals by offering technical and soft skill trainings related to building science principles, high performance buildings, marketing, and communication techniques. And then we have our home energy savings program, which incentivizes contractors and helps residents save money and to make their homes healthier with energy efficient upgrades through incentives and rebates. And with that, I'll pass things over to Nick.
Thanks, Sarah. All right, pleasure to be with 3C Ren, one of the best run statewide education services. A lot of great courses you guys offer, and I enjoy working with you. I was just up in Cambria for the Quebec annual conference up in 3C Ren territory, and it was beautiful as expected, as always. Spent a lot of time up there, although I am in Long Beach. Here is my net zero all electric home. All electric as of about 2 months ago, because when we remodeled the main house in 2015, we didn't have the same strong signals to build all electric as we do now. Gas and electric options were treated interchangeably in the modeling software and really in the world of high performance homes. And so we ended up putting in a gas furnace and a gas tankless water heater and a gas dryer, although we got the induction cooking right. But when it came to build the ADU, which is above the garage on the right side of the screen here, 2 years ago, the signals were clear. The state had set many aggressive climate change related goals to reduce greenhouse gas emissions, and all electric buildings are way number 1 to achieve that goal. In many ways, the low hanging fruit to reduce greenhouse gas emissions in our economy, as we'll talk about more in the coming slides. So we built that ADU all electric from the start. It's worked great. The tenants loved it. And there's some wonderful incentives right now to retrofit existing homes with gas systems to all electric. We took advantage of those and got rid of the last few vestiges of gas in the main house put in a heat pump water heater in place of the gas tankless water heater on the side yard, 120 volt unit. So, pretty simple to do. And then replace the gas furnace in the attic with a heat pump. We'd already replaced the gas dryer with a heat pump dryer as well. So I called our local municipal gas utility and they sent a guy out and removed the gas meter. Very satisfying experience. So yeah, I'm living this all electric modeling topic every day with my home and the ADU as a laboratory for it, and my practice as a Title 24 consultant, an additional laboratory, because I'm modeling all electric projects all the time. Sometimes for clients, who are electric cautious, let's call it, I'll show them a mixed fuel option for compliance and an all electric option for compliance. And that's what I want to walk all of you through today. A combination of why electric homes are important, the energy code requirements that give us a strong nudge in that direction, as well as the incentives, how to model all electric in CBEC Res and Energy Pro, and how those all electric designs perform compared to gas mixed fuel designs. Several code cycles ago, it might have been true that mixed fuel designs with gas systems outperformed all electric. But today it is no longer true, not even close to true. You're going to get improved energy code compliance with all electric systems, and we'll show you how to get the most value out of those electric systems on your compliance scores. And then we'll share a few lessons from the field, because you're a diverse audience. Energy consultants, you're holding the hand of the developer or the architect or the owner on this electric conversion that they may not always be familiar with. So it helps to know some common hurdles to clear on heat pump water heater installation, for instance. You might be HERS raters, so we'll talk about some of those verifications in the field that are required for all electric homes might be slightly different. You may be building officials like George from Nevada County. You may be all kinds of different perspectives on this. And it's important not just to get the modeling and the CF1R compliance form right, but get the field installation right too. Sarah, we good so far?
Yeah, we're good.
All right. So let's start with why we're here talking about all electric homes all of a sudden. This quote jumped out at me. It's from a White House report on accelerating and smoothing the clean energy transition. And I like the language that they use. This transition would constitute a transformation of the energy system at a pace without precedent. So this is a big undertaking and mark a giant achievement in human history. I've come to believe that this clean grid transition, this transition of buildings from fossil fuel to combustion to electric, is one of the major transformations in human history. I know that sounds like I'm overstating it, but it is a big deal to move from running the world on fossil fuels to running it as much as possible on renewables. And so I think I share this quote because it shows it's an important undertaking, one that's going to take all of us pulling in the same directions, and really important to get right. Now, here's the piece of the argument for electric homes that I didn't get when I remodeled my house 8 years ago and included gas. All electric homes have roughly half the greenhouse gas emissions as mixed fuel homes. That's a huge difference. I was looking at energy in terms of kilowatt hours and therms and trying to equate therms into equivalent units with kilowatt hours, I wasn't aware that the greenhouse gas emission difference was so stark. And this takes into account California's goals to green the grid over the next, 20 years roughly. By 2045, we've set the goal of 100% emission-free electricity that'll be supplying these homes. And that's where the biggest part of this difference comes from. And if you looked at this stacked bar chart, you can see the difference is consistent across climate zones. I show San Francisco, Santa Barbara, Riverside, Corona, and the East Bay in this particular chart, and it's pretty consistent. And you can also see the biggest reduction is in the orange bar, water heating, and in the heating and cooling bars. It's important not to ignore utility costs in this whole thing. So we did a study comparing a mixed fuel design to a standard heat pump design and then to a best-in-class variable capacity heat pump design. And we found that with the Title 24 required standard amount of PV, the utility costs may go up slightly for that conventional heat pump versus the old status quo from 620 to 720. But as soon as you add one extra PV panel, that conventional heat pump design comes out ahead. And that extra PV panel costs you what? $1,000 or something. So it's going to pay for itself quickly, 9% savings. But if you go to the best-in-class heat pumps, which I would argue is the best practice, you're coming out ahead even before that additional PV panel. And adding that PV panel, you're coming out well ahead, 28%. So these common perceptions that gas is a cheaper way to power homes than electricity just don't bear out when you take into account solar panels on the roof, and potentially when you're doing all electric designs, it's a good idea to look at an incremental extra PV panel or 2 or 3 or 4, especially if your clients are considering EV charging or have pool equipment. So those of you who are energy consultants, architects, supporting the building owners with their projects, we need to increasingly look at utility costs as we make recommendations on electrification, help them decide the optimal solar system size. So here are just some of the commitments our state has made that end up taking the form of our energy code. Our energy code is in effect how we achieve some of these goals. 40% greenhouse gas emission reduction by 2030, economy-wide, but also for buildings as a whole. That's AB 3232. 100% carbon-free electricity by 2045. That's SB 100. Carbon neutrality, incentives under the Tech Build program. Internal combustion engine car sales ending. Not to mention at the international level, the Paris Accords pushing a greenhouse gas reduction, and then certain federal efforts lately with the DPA and the IRA. Not just California acting alone anymore. So gas has been thought of as a transition fuel from fossil fuels to intermediate stage to more and more renewables. But the cost of renewables is now lower per unit than natural gas. So what we're seeing as the grid evolves is more and more wind and solar especially paired with battery backup to manage intermittency and uncertainty, and not as many natural gas plants being permitted. In fact, multiple natural gas plants that were proposed ended up not getting built because of how renewables and storage and load shifting are a lower cost way of achieving the increased electricity supply we need. So these renewables work and can be less expensive. Also, the chart on the right I wanted to show you, this is from the CEC's IPER, predicts a market increase in gas rates over time compared to electricity rates. Now, electricity rates, in honesty, have increased over the last few years. Can't gloss over that. But the gas rates are predicted to increase at a much higher rate. So electrifying your home, in effect, removes this exposure to fast increasing gas rates. And the reason for those gas rates shown on the right y-axis are expected to go up upwards of $6 a therm is because the fixed costs of the gas distribution system end up getting borne over a smaller and smaller group of ratepayers as the expected transition to electrification happens. And in fact, the electric utilities are finding that better utilization of the electric system can result in lower rates over time. The dots on this chart are where the electric and gas rates were just in recent history. We had a big spike up into the $4 or $5 range for gas. We have marginal rates in the high 30-cent average rates, sorry, in the high 30-cent range. So you can see these trends upward on gas rates are already happening. And so the argument I'm trying to make here is that electrifying your house can protect you from those uncertainties, potentially high rates. And this world of incentives has changed a lot. It used to be we had a small incentive for solar panels, 10 years ago when that was an emerging technology. Then we didn't have a whole lot to offer our clients to electrify, but now we do. I just did a typical all-electric retrofit, and many of these incentives can stack on one another. So taking one doesn't disqualify you for another in many cases. So the Energy Smart Homes program was the one that we qualified for with our home retrofit. I think it's $5,550 if you submit this year, goes down slightly over time, with additional kickers for a heat pump dryer and electrical panel upgrades. Then the Tech Clean California program offers incentives to installing contractors of $1,000 each for a heat pump and a heat pump water heater. And the IRS tax credits stack on top of that up to $2,000 for a heat pump and a heat pump water heater, additional for efficiency upgrades and electrical panel upgrades, even an AQMD rebate on EV chargers. So brings you in the $15,000 range. That can pay for a lot of electrification upgrades and really make the economics of the project work. If you work in the area of low income, that can double with the addition of the HERA program that's coming through our CEC, our state energy office, through the Federal Inflation Reduction Act, with up to $14,000 in point of sale discounts for low income customers under 80% of the median income. And there you see the possible incentives, with that, the big one being for the heat pump. So imagine working in those disadvantaged communities in your area to do electrification of existing homes and being able to bring this kind of incentive stack to work for you. Wanted to make sure you're aware of all that. Don't see any questions, but does anyone have any before we move on to the energy code requirements that push us in this direction? No? All right. Well, the first big change in the 2022 energy code was setting heat pumps prescriptive standard. And there's a heat pump prescriptive standard in every climate zone of the state. Not all heat pumps are required, but no matter where you are, either space conditioning or water heating are going to be prescriptive standard, are currently prescriptive standard now. So that forms the baseline for energy modelers like Cosima to demonstrate compliance with the energy code. So that was a big switch. In the past code cycle, we had gas baselines, gas prescriptive standards. Now we've got either a heat pump or a heat pump water heater prescriptive standard. And you'll notice that, let's just look at this map a little for 3C REN territory. You've got some of climate zone 4 in 3C REN territory, all of climate zone 5, some of 6, some of 9, and some of 16. So you've got a really interesting group of climate zones covered here, from mild coastal to Paso Robles to Santa Barbara to Santa Paula, and then into this Ojai range is the same climate zone as the Sierras. So really interesting, challenging group that you guys work with. The other big change was this electric ready requirement in the 2022 energy code. And this is, rather than show you the code language, I thought I'd show you a visualization of it. If we install a gas system for any one of these 4 end uses as part of our energy code compliance project, we're going to be required to provide for a future electric retrofit of that appliance. So if we put in a gas dryer in a home, and this applies to new construction only, by the way, we're going to have to wire for a future electric one with the conduit and the circuit and the space reserved in the panel. Similarly, for a gas furnace, we need to provide for a future heat pump. That's a 240 volt, 30 amp circuit we need to reserve there. Gas cooktops require a 240 volt, 50 amp circuit for a future electric range. And the gas tankless water heater requires you to provide the space for a future electric heat pump water heater and the circuit. So these are what, I was an econ major, we called these nudge policies, because they aren't outright regulatory thou shalt be all electric policies, but they give you a nudge in the direction that, as we showed with the greenhouse gas chart, is preferable for the state, because it drives up the cost of the gas system when you have to add the electric circuit relative to the electric system, which is going to have that circuit installed anyway. So those who might have chosen gas without this policy now are going to give electric a longer look. Then range hoods. We've long had code requirements that are mandatory for indoor air quality reasons, that we have hoods that are not too loud and that provide the necessary airflow above our cooking equipment. But in 2022, these transformed into another nudge towards all electric, because as you'll see, the CFM required over gas ranges in this chart are higher than the CFM required over electric ranges. This recognizes the fact that gas cooking creates additional harmful pollutants that electric cooking does not, and therefore a higher rate of exhaust airflow is warranted when cooking over gas systems. So this might make someone choose the electric cooking option so they can pair it with 150 CFM hood instead of a 280 CFM hood. Note that it's incorrect to assume there are no pollutants created cooking over electric. There's moisture that needs to be evacuated. There's just normal cooking byproducts from the food itself that need to be evacuated. But what's missing is the nitrogen oxides, the formaldehyde, the combustion byproducts. The other major change that gives us a push in the electric direction is the compliance metrics. When we went through the 2016 code cycle, which took us through 2020, right? Well, 2019. Our compliance metrics for new construction additions and alterations were time-dependent valuation. There was no recognition of solar and renewables in our compliance metrics. It focused entirely on the efficiency of the house. And TDV meant that peak periods were weighted more heavily than non-peak periods. Then in 2019, we added the solar mandate for new homes, and we converted those TDV compliance metrics to energy design ratings on a scale of 0 to 100. And we had to meet one for efficiency, ignoring any renewables, and a second compliance metric we called EDR total that reflected the right-sized solar system and or battery system. So that set of two compliance metrics for new construction took us through until the 2022 code started, January 1st, 2023, when we added a third compliance metric. That third compliance metric, in addition to building an efficient house as measured by EDR efficiency with a right-sized solar renewable system as measured by EDR total, now we need to build a building that complies with the EDR source metric as well, at the same time as efficiency in total. That EDR source metric is a proxy for carbon emissions of your design. So your proposed designs being compared to the prescriptive standard design in terms of carbon emissions. So if you design a system that has higher carbon emissions than standard, you're going to have a hard time complying with that metric. So guess what? Types of homes that source EDR metric disadvantages. Those with gas combustion, right? Because they inherently have higher carbon emissions. So this is a strong incentive for us to choose electric designs. Here's a quick slide on what's included in each of those metrics. So this is what energy consultants face with their modeling software output every day. You've got the standard source efficiency and total EDR, you've got to be under. You've got your proposed source efficiency and total EDRs, and only if you're under on all three and thus have positive compliance margins on all three, do you get your complies message and you can submit that for permit. So besides electric ready provisions, prescriptive standard heat pumps in every climate zone, and the new compliance metric, we have a carrot in the modeling world, and that's the compliance benefit of these all electric systems. Heat pumps and heat pump water heaters can provide significant compliance boost in the 2022 software. Heat pumps, just a standard central heat pump code minimum efficiency gives a 5% boost to efficiency EDR on average across climate zones and 18% boost on source EDR. There you see with the source EDR comparison, the impact of combustion versus electric. The VCHP, which we'll talk more about These are mini split heat pumps that are inverter driven, that adjust the delivery of heating and cooling up and down in a wide range according to the load in the space, as opposed to the jet engine furnace and air conditioners we all grew up with that were single speed, either on or off. So VCHPs unlock a lot of additional efficiency by being able to ramp down on mild days and work at low load where they're much more efficient. So with those systems in your model, taking advantage of the VCHP compliance credit, 17% efficiency EDR and 24% source EDR savings are possible. Those are huge. Very few measures in modeling move the needle that much. On the water heating side, a generic heat pump water heater can give an 8% efficiency EDR boost and an 8% source EDR boost. Upgrade that to a near tier 3 unit, 10%. And if you enter a specific make and model heat pump water heater, that unlocks the full compliance credit of heat pump water heaters. So the one I tried, 17% efficiency EDR and 30% source EDR. So the lesson there is, if you can work with your client to specify a specific make and model heat pump water heater, you can get a lot more credit than just modeling generic. We'll talk more about that in a minute. So here it is by climate zone. Here's heat pump impact on 2022 compliance margins on efficiency EDR of a central heat pump, the yellow bar, just code minimum, standard, single speed, and the variable capacity heat pump in blue. You can see even the central heat pump providing positive compliance improvement, but the VCHP is a lot larger positive impact. And you see that in climate zones 4, 5, 6, 9, and 16. The only exception being that climate zone 16 central heat pump is a slight negative, but with the VCHP, you wipe that out. And not a whole lot of climate zone 16 in 3C REN territory. Here are the water heaters. And you see generic in yellow, NEA tier 3 in blue, make and model specific in orange. So you can really see how entering Ream or A.O. Smith or Bradford White or Sanco 2 can unlock the full compliance benefit. The other thing encouraging electrification is the solar mandate, right? We've had this a couple code cycles now. Here's the table that's used to calculate the amount of solar. But there's a wonderful crossover synergy between producing electricity on your roof and using electricity in your home. Again, don't blindly size your solar system to code minimum. Look at a couple of extra panels and see if that's cost effective on your projects. And VCHP is a strong credit. These are mini split heat pumps that modulate the delivery of heating, cooling to match the load in the space. They're monitoring indoor and outdoor temperatures continuously. They're quiet. They're small footprint. As you see, this suitcase style condenser is great for narrow lot lines with long lifespan because they run at low load a lot of the time. And as measured by SEER rating, can be 60% or more efficient than standard equipment. Soon the software, we're told, will extend the VCHP credit to a wider variety of ducted units. That VCHP credit has been easy to take advantage of for ductless mini splits, tougher to take advantage of for ducted mini splits, but we're told we're going to get a new compliance option. And I'll show you a few screenshots of that from the research version of the software here in a minute. So I'm about to take you through some of the screens that we use to model all electric homes. Are there any questions, comments, thoughts, perspectives from your work anyone wants to share? Nothing. Okay. But I always make sure I pause in case there is, and it kind of reminds me of when my kids used to watch, childhood TV shows, and the host would, especially, who would do it as Dora the Explorer. She'd stare at she'd stare at the screen and blink a few times. That was so fun. Anyway, all right, specifying a heat pump. Not too tough, but for those of you who aren't familiar with the modeling software, let me just walk you through it. These are CBEC Res screenshots. And you can see on the left box, we're specifying a central 3-ton heat pump. And in that type box is the drop-down menu that gives you a wide variety of heat pump options to choose from ductless mini splits to ducted mini splits to these central to VCHP. So you're going to need to specify the capacity in BTUs of your heat pump at 47 degrees and at 17 degrees. These numbers will come from your manufacturer's spec sheets or AHRI's website, NEEP's website. You can find them several different places. In Energy Pro, these are the screens that you use on the right side of the screen. It's all the same information, just the user interface is formatted differently. You can see the heating tab on top here. We've also chosen the same 3-ton central heat pump here. And then the cooling tab is on the next page. And here is the drop down showing the wide variety of configurations that are supported by the software. CBEC Res on the left, Energy Pro on the right. Notice the VCHP compliance credit highlighted on the CBEC Res is on the drop down, whereas if you want to take that credit in Energy Pro, it's on the residential tab, just in a different spot. Heat pump water heaters are defined under the domestic hot water system. And here you can see it's a 2-level specification in CBEC Res. You're going to define a domestic hot water system here called HPWH with a water heater under that. And the water heater box is on the right side of the screen here. Here we've chosen a generic NEA Tier 3, 50-gallon or more heat pump water heater. Notice we have to specify the location of the heat pump water heater because unlike gas and electric water heaters, which create all of their own heat, burning a fuel or using electricity, heat pump water heaters interact with the place you put them a lot more. So the software is going to model them differently if they're located outside, as in this model, in a garage where the temperature be slightly different, or in the conditioned space. So there's a few details to work through with your client on location of that heat pump water heater that wouldn't be necessary with an electric or gas water heater. In Energy Pro, same information, different user interface structure. You see the DHW system defined on the left and the water heater defined on the right. In both cases, though, the software comes with a database of approved makes and models. You can select the manufacturer and the model that you want to use to fully unlock the compliance credit, or you can leave it generic as shown here to give the field the most flexibility to install what they want. In multifamily, the process is a little more complicated. There's CBEC Res screens shown here. I know a couple years ago, I was floundering. I didn't know how to consider specifying a heat pump water heater in a central format for a multifamily building. But we're learning. We go to the KBEC conference. Companies like Gable Energy are great at sharing what they've learned about this, and the software has come a long way. It can now model central multifamily heat pump water heater systems serving multiple units, as shown here. In CBEC Res for multifamily buildings, you're going to define dwelling unit types, is where you're going to say if your appliances are electric or gas, if your washer dryer are central or in the unit, heat pumps and heat pump water heaters shown here, or gas equivalents if you're using them. And then you define those on the mechanical tab. Here you can see we've defined a central heat pump water heater system serving the 8 units in this building. No, I'm sorry, this is a 36 unit building, I believe. In this case, we've put together 8 make and model specific heat pump water heaters in an array. We've located them outside. There's an electric resistance swing tank, 80 gallons. And all the details are specified here, and the software can model that. Of course, the software can also model non-central water heating, where you put 1 unit in each unit. Appliances are non-regulated in CBEC Res. They don't help or hurt compliance margins, but they do change your output, which is important for you when you consider total electric use, net of PV over the course of the year, and you think about sizing the solar system. Plus your plan checker, if you're saying you're going to build something all electric, they're going to expect to see it actually be all electric. So those are defined in CBEC Res here under the appliances tab, and in Energy Pro in the zone menu. And as I said, we're excited. We're about to get a detailed VCHP credit unlocked in the software that will extend compliance credit to these mini split heat pumps that are inverter driven and variable speed from the ductless units that we can currently take advantage of the standard VCHP credit to mid static to high static ducted mini splits that can be hidden in drop ceilings, boxed in the attic for best practices. And you do so with this detailed performance data screen shown on the right, where you put in the capacity and the efficiency. The COP is the measure of efficiency, minimum and maximum at 5 different temperatures. And these come from the NEEP database shown here, where the manufacturers have given all these detailed performance curves. Well, now the software, CBEC Res and Energy Pro, are going to soon be enabled to model every hour of the year using these performance curves instead of the standard VCHP modeling option that was a simplification or sort of average performance. We've done a extensive modeling study on these detailed VCHP modeling routines, and it appears to offer, some heat pumps are going to perform even better than the standard VCHP. Others are going to be in between the standard VCHP and a what we call a dumb heat pump that's single speed. But either way, we've got compliance credit possible where we used to have none. So this could do a lot for electrification, this detailed VCHP option when it's unlocked. And I thought we'd use an output screen to illustrate some of these concepts. Take this one. This is a garage to ADU conversion from our practice. It was a 410 square footer in climate zone 5. We put a 2 kilowatt solar array on it, although it wasn't required by code. And look at what this software tells us. It tells us the standard design, electricity and gas that the building's using. So 77 kilowatts of heating, 12 of cooling, and 889 of water heating. And then it tells us our proposed design. So there's all kinds of signals that we can get from this type of output. First of all, we can see our building, our proposed building, using a lot more heating energy than the standard building, a little less cooling, a little less water heating. And overall, we're not in compliance yet. We're 25% away from compliance. Note that PV isn't a help in this area because it's not required by code, but it's just noted here for our design purposes. Now let's read down that proposed column, and you can see the unregulated loads are added in there. Interior lighting, appliances, plug loads, for a net over the course of the year of about 1,000 kilowatt hours. That's interesting to know, isn't it? Our software can guide us on solar sizing, on managing utility costs, if we just use the data it gives us instead of stopping at the compliance total line. So we might decide, we've got a budget-minded homeowner here. Let's add, that was 2 kilowatts, gave us 3,300 kilowatt hours. We need another 1,000. Okay, we add another 0.75 or 2 or 3 panels, and we'll fully zero out the electricity use. The other hints we get here are, we should work on heating, shouldn't we? Something in our model is driving up that heating energy use. It could be a lot of glazing. It could be an under-insulated cathedral ceiling, less insulated walls than standard. So really use this software modeling output to guide your design, both for compliance reasons and beyond compliance design choices. I'll pause again and give you the Dora the Explorer blink. Any questions, thoughts? All right. We'll leave room at the end as well. Doing good on time. Now let's get to how all electric performs against gas. There's the screaming headline. It makes compliance easier everywhere and significantly easier. This was a study across all climate zones where we compared new home overall compliance margin with mixed fuel and with all electric. And this was the improvement for going all electric. 16% efficiency EDR, 50% source EDR improvement. The number one thing you can do to fix that source EDR is switch from gas to electric. But let's drill down into some details here. This also follows for multifamily buildings, although I've found the impact to be less substantial on multifamily, but still significant. Here we took a 36-unit multifamily building in climate zone 8, but you'll see similar relationships in 3C REN. And we modeled the impact of the gas upgrades, like a improved central gas boiler for water heating, improved HVAC split systems, high performance walls, triple pane windows, and we compared the impact of those to just going all electric with a central heat pump and individual heat pump water heaters, and then with ductless VCHP. And you can see the compliance impact of the electric options is as good or better than the best compliance options for gas. Here's another example. This was a dual fuel model from our practice that was 10 source EDR away, 4 efficiency EDR away, and by switching it to all electric with the VCHP, you know, that's all it took to have a healthy, positive compliance margin. Really powerful stuff we can get from all electric. Then we did some new modeling in 3C REN territory, 4, 5, 6, 9, and 16 shown here. This was a new single family home, 2,100 square feet, 3 bedroom, 1 story, like you'd see all over 3C REN territory. And we modeled it first with code minimum gas systems. And those are the red and orange bars. They're negative. They're not in compliance. You can see on efficiency or source EDR. And by switching to code minimum electric systems and make and model specific heat pump water heaters, boom, those EDR margins popped to the positive significantly in all of those climate zones. And that difference was even more stark in Ojai than the others. Then we looked at multifamily. We took an 8-unit building, and it wasn't as stark, but it was still a significant improvement for the electric over the gas in every case. You see the site margin and the source margin. Notice the compliance metrics are different between single family new, multifamily new, and additions and alterations, which I'm going to show you next. So that's why the units on the y-axis differ. But you can see the site margin improves considerably with electric, the source margin even more so, and across all of these climate zones. And then we did an addition alteration. Maybe many of you do projects like this. Additions and alterations only have a simplified TDV compliance metric, a single metric. So we're showing gas TDV and electric TDV here. And you can see the same holds true. The electric compliance margin is significantly better than the gas compliance margin. This was a typical addition project from our practice, 940 square foot home with a small addition. So all different flavors of projects can benefit from electric designs. Now, I thought I'd share a few lessons from the field, and then I hope we can open it up to your experiences in the field, questions. So there are a few considerations as we transition from specifying and installing typical gas systems to heat pumps. First and foremost, the HERS rater has to verify the capacity of a heat pump matches the compliance form, the CF1R. And for those of you who aren't completely familiar with HERS rating, you know, energy consultants prove compliance with the code through the CF1R form. That's the compliance form. And they specify a certain heat pump. Remember, I showed you in the screen, you have to put in the capacity at 47 Fahrenheit and 17 Fahrenheit of your heat pump, where that's not required for a gas furnace. The software just sort of auto sizes it and doesn't worry about it with a gas furnace. So this is an additional requirement we have to consider. And the reason for that is heat pumps often come with supplemental electric resistance heat strips for those coldest days of the year to give a little bump in capacity if the heat pump's falling short on capacity. So you can imagine if you've got a house with a maximum heating load of 40,000 BTUs per hour, but you put in a 16,000 BTU per hour heat pump, well, that electric resistance is going to run a lot. And electric resistance has the problem of being 1/3 as efficient as heat pump operation. So it can wreck our our real world performance of a heat pump if it's not sized right. That's why the HERS rater has to file their CF3R verification form after visiting the house saying, okay, what they installed matches what the compliance form said in terms of capacity. It's at least, let's say in our example, we had 36,000 BTU per hour at 47 and 30,800 at 17. So your HERS rater is going to verify that what was installed was at least that capacity so that we don't run into a problem with an undersized heat pump. There's also verifications for that HERS rater to do if we're taking the VCHP credit. Remember, that's the inverter-driven mini split heat pumps that are so much more efficient than single speed ones. And that HERS rater is going to have a few forms to upload saying, you know, there's an indoor unit for every 150 square feet. There's wall-mounted thermostats. And if it's a ducted VCHP, there'll be some additional verifications for them to file. The other thing that's a little different with heat pumps is they're way more flexible in terms of configuration than the typical gas furnace split systems we've always installed, which tend to be one for one. We've got one indoor unit, usually a big air handling unit in a closet or up in the attic, connected to the outdoor unit for cooling. With mini splits, with heat pumps, we could have a similar configuration, one indoor unit ducted, one outdoor unit, or we could have multiple high wall ductless mini splits all over the house linked to a single outdoor unit. So or a mix of ductless and ducted connected to the same outdoor unit, multiple outdoor units and indoor units. So the verifications that happen out in the field, the installation complexity can be different because these systems are capable of much more flexible installations and more efficient operation. So we need to keep that in mind as we enter this heat pump transition stage.
And Nick, there was a question in the chat. George asked, what software or app do you recommend to help multiple ductless heat pumps work together optimally and respond to actual motion of residents?
That's a thoughtful question. As a project, we always used to say in business school, staple yourself to an order and you'll discover, you know, the problems in the process. So if you staple yourself to a set of plans, those plans go to the energy consultant for an energy design for compliance purposes, right? They go through the city, they get approved. As you can see in this slide here, sometimes they boomerang back to the energy consultant for edits before they eventually get approved. And then those set of plans go to a general contractor to get bids. Hopefully the HVAC contractor has been involved before submittal to the city. They've weighed in on proper sizing. They've weighed in on combination of ductless and ducted units and where the outdoor unit will go. And in that case, George, they've done the thinking that you're pointing at with your question ahead of the last minute. But if they haven't, if the set of plans we're stapled to went in for a plan check before an HVAC contractor really weighed in, well, we've made some assumptions. We've estimated capacity of the heat pump or gas furnace, and that needs to be refined once the HVAC contractor is bidding on the plans. So they are required by code to do load calculations and size the system appropriately for the loads. And at that time, they'll be piecing together indoor and outdoor units, fan coils and condensers, and designing the system for that space. So it's really the HVAC contractor or MEP engineer, if you're doing larger projects and that use those professionals, who should be deciding on the configuration of the HVAC system. Now, a lot was spoken about energy consultants playing a larger role in this design process at our recent KBEC conference in Cambria, because there's a recognized room for improvement in the industry on HVAC system design, from what's traditionally been rules of thumb based on square footage and that HVAC contractors' past experience, to actually doing load calcs as required by code, and working with manufacturers' tools. Some of the manufacturers have software tools to optimize those combinations of systems and size them to the modeled loads. So this is a really important area you're poking into here that is far from settled, and our whole industry needs to focus more on heat pump sizing, heat pump design, work with HVAC contractors earlier in the design stage to make sure we're fully recognizing the potential of these systems to deliver utility cost savings, improved comfort, and lower greenhouse gas emissions in our buildings. Longer answer than you bargained for, perhaps, because it is, we've been talking in the Energy Consulting Association and offline on emails a lot about this topic lately. Thanks for that. So we really need to bring in that HVAC contractor and work with the architect more in the early CF1R stage, rather than using incomplete HVAC information to upload a project to the HERS registry, because often the HVAC units that are installed are different than on the CF1R. We have to revise our CF1R because the architect sends plans back for revisions, and this can move a few times in this circle, a non-productive circle, before finally they're approved and the HERS verifications get matched to the CF1R. So submitting the CF1R isn't the end of the process. It's just the beginning of the process, and it triggers CF3R verifications by the HERS rater that'll be required for final C of O by the inspection. Also CF2Rs that are filed by installing contractors and builders saying, I installed what was on the compliance form. So recognize that compliance form needs to be revised as things change in the field. And one way, to George's question, is quick model software or RightSoft, to specify these best practice, best in class heat pumps without the boomeranging problem. We need to one, size them right. And Energy Pro has a load calc module that can help with that. Quick Model is a manual J sizing program that we've recently begun using in our practice. And you build a house visually in 3D as shown here. This is a screenshot from it. And design an HVAC system with supply registers for each room. So that's a great best practice for us as energy consultants to start supplying real energy load, HVAC loads at the time of design to the architect to stay with that project as it goes and gets refined by the HVAC contractor. That way we're not leaving our project to rules of thumb for sizing. And CBEC Res, I would argue, needs to simplify our energy consultants' access to those load calcs like Energy Pro has. We got to get the number of systems right. Because if we do this two-story house shown here with a single HVAC unit, and they end up using two HVAC units, as they often do for two-story homes, we need to revise our CF1R so that the HERS rater has two systems to file forms against. That's one of the most common reasons I end up revising CF1Rs. If they're ducted or ductless, we've got to revise our CF1R. If the efficiency we assumed is higher than actually installed, we need to make revisions. And by the way, that one can result in the need for additional design changes if the installed unit is minimum efficiency 14.3 SEER, 7.5 HSPF2, and we modeled something more efficient than that in order to achieve compliance. Boy, we may have to upgrade above roof deck insulation or remove some glazing to get the model to comply. So all this to say, energy consultants may be specifying equipment or just using code minimum assumptions for their models to avoid problems in the field. Energy consultants may be forcing the architect to talk to the HVAC installer earlier in the design process so that we get the number of systems right, we get the ducted ductless configuration right. Now, a big consideration in electrification is the panel. And a lot's been said about, oh, we could electrify, but then we'll need a 400 amp panel to make room for it all. And I'm here to tell you that Watt Diet is a great tool to check on what your electrician is telling you about the need for a panel upgrade. This is the National Electrical Code put in a spreadsheet, and you enter information about the size of the house, which drives the baseline loads. You enter the systems you plan to install and their voltage and amps. On this screen, the heat pump comes through from another sheet where you've put in the loads. And all this is added up, and it tells you the minimum panel size per electrical code for that set of loads. In this case, 125 amps. Even with an EV charger, as you see in here, a heat pump water heater, a heat pump, a full power induction range. So there are definitely cases in our practice where there's a 100 amp panel or something, there's a large house, the people want to add EV charging and pool equipment and solar and battery. Okay, it's time to upgrade your panel in that case. And I would argue that it's not electrification that's the villain driving this panel upgrade. It's progress. It's the advent of solar panels and EV charging. You basically got the ability to fuel your car in your own home that you never had before. Yeah, that takes power. So think of the electrical panel upgrade as future-proofing rather than caused by electrification. In most cases, that's going to be the case. And remember, in the incentive slide we started with, there are some incentives for electrical infrastructure upgrades and panel upgrades, including tax credits. So be sure you take advantage of those if that's part of your project. But Watt Diet is free to download at Redwood Energy's website, and the link will be shown in your PDF. By the way, I'll be getting the PDF to Sarah to distribute to you after the class. So your electrician tends to be risk averse on sizing your electrical panel. They generally err on the side of having too much power, but you can help the process by showing them your monthly electrical usage. Studies show that actual peak usage is lower than what the electrical code even suggests it's likely to be, because all your systems are very rarely on concurrently. Give them the power requirements of your new systems so they're not making assumptions that are incorrect. Ask them to show you their calculations and make sure that you are future proofing for those other electrical uses you have planned. If you already have air conditioning, a heat pump provides heating with no extra power. That same circuit should be adequate for your heat pump, interior and exterior units. In fact, with VCHPs, the interior units are usually powered from the outdoor unit with wires run through the walls. Heat pump water heater, heat pump dryer can both be installed 120 volt versions, not 240 volt versions, although both also come in 240 volt versions. So if you find yourself power limited, by all means, go to these 120 volt options. There's even an induction range that's being made by a startup called Channing Copper that's 120 volts, has an onboard battery. So solutions are coming online all the time to make electrification possible with less power. Existing homes often have more power allotted to lighting than is necessary because those were incandescent lighting circuits and now you're LED, so you can rework that too. And if all that fails, circuit sharing devices can allow you to make sure two large energy using circuits don't run concurrently. They need to be chosen carefully, such as EV charger and stove, EV charger and electric dryer. You can have combined washer dryers. There's the Channing Copper induction range. You can install an EV charger not with 50 amps, but 20 or 30. It's going to go a little bit slower. But in my experience, these are often oversized relative to what's needed. A few other lessons from the field from our sometimes painful experience. Heat pump water heaters are different animals than gas water heaters, than electric water heaters. They interact with the air around them. So we need to provide airflow to the water heater. Unlike in this example shown here, this was a closet off the garage. You can see the pipe on the left side of the door. That's going underneath the ground to the main house to the left. And the heat pump water heater was installed in this closet. Look at the airflow allowed for that heat pump water heater. It's about half a square foot. Nowhere near enough for the outside air to go in that heat pump water heater is pulling heat out of, and the outlet air to exit. So this heat pump water heater installation failed miserably at first. It also had a recirc timer on it, which was on a program and just pumped hot water underground to the house at 5 a.m. so it'd be ready for the occupants. So this was just a bunch of compounding errors on top of each other. They also had high flow water fixtures in the shower. I think he said it was 6 gallons a minute or something, whereas, code says 1.8. So do provide adequate airflow, do upsize tank size because heat pump water heaters are energy sippers. They recover a little more slowly. You may need a 65 or an 80 gallon unit for a large house where the 50 gallon gas may have been adequate. Don't leave those high flow fixtures and don't allow the recirc pump to drain your capacity. On the heat pump, best practice, locate the outdoor unit, make sure you have room for it, make sure you have power there, and the indoor units. Heat pump water heaters, you need to locate those too based on power availability and the location of the hot water lines being the two main considerations. also floor space availability. Cooking, you may need to upgrade that electrical circuit. Our induction range is 240 volt, 40 amp. And the dryer may need 240 volt, but they also make 120 volt units. Mine is a Miele 120 volt heat pump dryer. It works great. So that's what we prepared for you today. This was a brand new class, so really like to get your feedback on it, either via email, or maybe Sarah, do you have a survey to distribute at the end?
Yes, yeah. So there will be a survey in the follow-up email that will be sent out to everyone with the recording and the presentation slides. We also have just a quick Zoom poll that I just went ahead and launched. It's just more general questions about kind of like high-level course usefulness. So if folks could fill that out too, that just kind of gives us that high level. And then the survey that goes out in the email kind of digs in a little bit deeper, but it's still only, I think, 4 questions. So it's pretty quick.
Great, thank you for doing that. Love to see the results, as this was a brand new class for us, and it had a lot of different audiences to fit, and a lot of climate zones to cover that are all very different. But, you know, bottom line, we find a lot of benefit to designing all electric for code compliance, for reducing carbon emissions, for comfort, for utility costs. That really is the low-hanging fruit in our decarbonization of our economy.
Yeah, and then George did just have a follow-up question from his original, just asking or clarifying that there is no specific app available for the multiple Douglas heat pump question that he had.
Yeah, the manufacturers often have software that they use to specify equipment. So you might look in that direction. But for load calcs, we showed Quick Model, we talked about RightSoft. Those are the sizing software applications. And then I think, Sarah, you wanted to cover a couple of closing slides?
Yeah. So just in closing, a reminder that there's continuing education units available, both AIA and ICC. I can submit those on your behalf. If you, during the registration, added your numbers, you're good to go. But if you need to add or give those to me, my email is there on the screen. I mentioned that you'll be getting the slides and the recording, and there's a survey in your email that should be going out in the next day or two. And then we're nearing the end of the year, if you can believe it, but the upcoming courses, I've added some links here for courses through the beginning of December. So there's still a lot of great content, a lot of great courses coming up, and we're in the midst of planning our 2024 Q1, Q2 courses. So keep a lookout for new courses coming in the beginning of next year too. Yeah, and with that, we can open it up for questions. And if you think of any questions after the fact, there's our info@VCREN. You can also email me. And it looks like there was another question in the chat.
About radiant floor heating. Yeah. I have a lot of clients who send over plans with the request for radiant heating systems. And sometimes those can perform better for compliance than the air source heat pumps. But, you know, I've come to believe that heating up the slab with hot water is not the best way to heat a space. First of all, you're heating up the slab, which has a lot of thermal mass and eats up some of your energy savings. Secondly, you don't have cooling. And I know we've had coastal communities that have built homes without cooling traditionally, but those days seem to be coming to a close in most of California as we just get subjected to more 90-degree days, even in coastal zones. So, bottom line, these heat pumps, air source heat pumps, are fantastically efficient, comfortable, and I try to talk clients out of radiant heating and cooling when possible. Those radiant systems typically require the capacity of gas water heaters as well to really keep up with demand, where the heat pump water heaters, because they're energy sippers, are great for domestic hot water, not really as well suited for space heating. Yeah, George asked about bans on gas appliances. Um, yeah, we're seeing a lot of activity here. There were many special interest groups advocating for an all-electric 2022 energy code. The California Energy Commission has to show cost effectiveness in everything that makes its way into the energy code, has to juggle the multiple stakeholder interest groups. And so they stopped short of that, although you saw every climate zone had either a heat pump or a heat pump water heater prescriptive standard. That doesn't mean they're mandatory, but it certainly sets the baseline and the expectation. There's all kinds of activity at the Energy Commission, at the Air Resources Board, at the various air quality management districts across the state to take extra steps and push us more towards adoption of electric systems because they're efficient, because they have lower greenhouse gas emissions. So yeah, we can definitely expect more steps in that direction over the coming years. And there's already been the internal combustion engine gas ban announced for sales of new cars in California. And there, I believe ARB has announced an end to combustion burning appliances in the system in the homes by 2035, I think. But there may well be additional requirements that move that date sooner. So yeah, there's going to come a time, it seems, that replacing your gas range with another gas range may not be possible, as well as other gas systems.
Okay.
I'll just ask a general question. My experience modeling all electric homes, solidly positive. Is that the experience of you guys out there who also do modeling? Any situations where you see different results? Because, you know, for me, these electric designs are outperforming in every case. Yeah, just what's your experience modeling all electric? Was it also favorable to compliance? Yeah. Yeah, a new experience for sure, especially the central heat pump water heaters in multifamily buildings, which tend to be complex, but starting to get a handle on that too.
Okay. Well, it doesn't look like any more activity in the chat. But if anyone continues to have questions, I added my email into the chat. You can always reach out. But if that is it. We can go ahead and end it here. Thank you so much, Nick, for bringing this new course to our curriculum.
Pleasure.
Oh, it looks like there was a comment from Sarah in the chat.
Yeah. Agree with that. And I'm sure Sarah's working on some of that workforce education.
Yes, yes, absolutely. I was just going to mention we are actively always looking to add new courses, new education, kind of focus in on different trades through our workforce education training program. So yeah, we're always trying to reach out and grow that education.
Yeah, and I think the heat pump education is needed, but the heat pump water heater education is even more needed. As you saw from that example of the small closet with inadequate airflow, there are some mistakes that are easy to make. So we need to get out to the plumbers and plumbing distributors and general contractors with that message too. And, hopefully we'll have a course to offer through 3C Ren in that area next year.
Yeah, definitely. Okay, great. Well, thank you all again for joining us this morning and hope you all have a good rest of your day.
Thanks, Sarah.
Thanks, Nick. All right, bye.
Bye.